Welcome to today's session, Streamlining Oracle Workloads from On-Premises to the VMware Hybrid Multi-Cloud. My name is Sudhir Balasubramanian. I'm a Senior Staff Solution Architect and the Oracle Practice Lead for VMware. I'm joined by my colleague, Ryan Kelly.
Hi, I'm a Staff Cloud Specialist, and I work on the VMware Cloud AWS service here at VMware.
All right. Thanks, Ryan. All right. So moving on to the agenda for today's discussion, essentially we start with talking about the benefits of running Oracle workloads on a VMware platform. We follow that up by some of the best practices. Then we delve into the Oracle workload design methodology, right? We'll touch a bit on VMware vSphere 7.x new features, talk a bit on high availability, business continuity, disaster recovery, touch a bit on talking about deploying and migrating Oracle workloads from on-premises to VMware Hybrid Cloud. And we would take VMware Cloud on AWS as the particular cloud of choice today. We'll wrap it up with a lot of collateral. So without much further ado, let's get started. All right. So let's take a look at some of the benefits of running Oracle workloads on VMware platform. So even before we take a look at some of the advantages of virtualization, right? Let's first understand what Oracle Business Critical Application or BCA requirements are. And then let's understand the benefits of running these business critical workloads, Oracle workloads on a VMware vSphere platform. So any application that's deemed business critical, right, or BCA will have certain SLAs. It'll have certain RTOs, it'll have certain RPOs. Essentially, what we're trying to say here is it'll essentially have a set of stringent requirements. So for example, availability. Well, this process must be, or this application must be highly available. It must be resilient. It must be redundant. Talking about performance, timely completion of any process is critical and must avoid all kinds of bottleneck, right? And the fact that it must be recoverable, which means the RPO, the RTO, the MTD, the WRT, they all must be very low. The recovery plans must be verifiable and repeatable. The fact that the application must be able to scale up, it must be able to scale out, it must be able to adapt and grow with little reconfiguration effort. And of course, it must be secure. So security is of utmost importance. So let's take a look at the Oracle workload design methodology shown in the slide here, right? We essentially start with the requirement gathering phase. We follow that up by selling the project to the stakeholders, essentially for buy-in. And that's followed by understanding the current environment constraints. We then follow it up by measuring the Oracle workload, the actual database workload. We then inculcate the database migration strategy. So whether we're moving from an x86 to an x86 platform, or whether we're moving from what's called the big endian, which essentially is the HP UX, the Solaris, and the AIX platform to the x86 platform, right? We follow that up by design considerations for sizing. We inculcate backup, we inculcate recovery. We also talk about high availability, disaster recovery, monitoring and tuning, and essentially support and licensing is of utmost importance. But if we take a step back, and if you look at all these steps of the design workflow, there is no one step that's particular to an architecture, whether it's physical or virtual. So all we're trying to say here is there are absolutely no changes in the design methodology when one virtualizes Oracle on a VMware vSphere platform, as opposed to running the same Oracle workloads on bare metal. So please keep in mind, the Oracle workloads, they basically have no idea. They essentially have no idea they're running on a virtualized platform. And the steps to provision, for example, the grid infrastructure, or let's say the RDBMS binary of a single instance database, or even Oracle RAC, it's exactly the same as one would do on a physical architecture. All right. So moving on to some of the performance best practices, essentially, the key thing to keep in mind, best practices needs to be inculcated into every layer of the stack. That includes the virtualization layer as well, to ensure that the workload that can take advantage of the underlying stack. So for example, when you look at, when you look at the Oracle databases on VMware best practices guide, we say use 4 para virtualized SCSI controllers, use 4 PV SCSI controllers, right? Make sure that the QDIP for the PV SCSI controllers and the QDIP for the VMDK are set to the maximum. So we are able to push as much load as possible, or as much IO as possible, right out of the workload, out of the virtual machine, right? The fact that you need to set the IO scheduling off on the guest operating system. The fact when you start looking at network adapters, we recommend using BMX Net3 adapters. And essentially, things which are very common, for example, like designing with NUMA in mind, right? Or making sure that you pre-test your workload. So we won't have time to go into each and every performance best practices, but all of the performance best practices have been documented in the Oracle Databases on VMware Best Practices Guide. The link is there in the bottom of the slide. Moving on.
So last year we introduced vSphere 7. There are a lot of new features that are specifically targeted at the business critical applications, such as running Oracle or any high performance type workload. We also introduced this ability to run Kubernetes on vSphere just directly in the hypervisor, and then some lifecycle management type of configuration management to be able to do upgrades in more seamless and easy push button type of way. But one of the things that really has been helpful for our business critical application customers is this new enhanced vMotion. So there's a lot of changes that were done to vMotion. It's used all the time in our customers' environments and data centers, but there were, it hadn't been really updated in quite some time. So we made a lot of changes to make it more high performance, as well as less interruption when you're actually doing the movement of virtual machines. And then a lot of improvements to the distributed resource schedule, or DRS, to be able to take advantage of some of those new features that we've added to vMotion, because we can do things a lot quicker with a lot less interruption or performance hiccups on your running VM infrastructure. So to dive in a little deeper on what we've changed, so previously in the older versions of vMotion, there was a significant impact on the overall in-guest performance. So there was a CPU spike that would cause, as soon as we did a vMotion, it would cause the application, if it were running at somewhere around 80 or 90%, to sort of panic, and there could be some sort of error or issue with those applications. So a lot of customers opted to turn off DRS and not vMotion, which isn't the best to be able to optimize and balance your vSphere environment. And then the switch over time, there was a longer, what we call a stun time or ping loss, when we actually did the transfer of the last bits of memory and the last writes that were cached. And so in the newer versions, we've greatly reduced the performance impact when we actually do the vMotion. And then we actually claim one vCPU of a VM to install the page tracer. So, lowering the performance impact during that memory pre-copy. And then the stun time is greatly reduced. It's either, under a split second or even no ping loss when we do the actual cutover. So if you're running business critical applications that are running at 80, 90% CPU and memory all the time, you can again now include them in the DRS groups to ensure you're able to switch over effectively, but also optimize and balance your clusters and your infrastructure.
All right. So let's change gear and talk about running Oracle RAC on a VMware vSphere platform. So essentially, the Oracle RAC and the VMware HA solutions, they are completely complementary to each other. So running Oracle RAC on a VMware platform, that provides what's called the application level HA, which is enabled by Oracle RAC. Now, VMware HA provides the infrastructure level HA, right? And if we were to run, or if we were to deploy this solution across metro distance, essentially stretching the Oracle RAC on VMware vSphere platform across metro distance, what that kind of configuration is what's called the running extended Oracle RAC across metro distance. That provides 3 levels of HA: the application level HA, infrastructure level HA, and site level high availability. And we get that simply by deploying extended Oracle RAC across metro distance. So why do customers deploy in the world, all around the world? Why do they deploy Oracle RAC on VMware vSphere platform? It's quite obvious, as it offers a lot of capabilities, right? Some of the capabilities include high availability, rolling patch upgrades, the fact that you're able to do workload mobility and workload balancing. So running Oracle RAC on VMware vSphere, that offers greater uptime than running Oracle RAC on a physical architecture. Another advantage of running RAC on vSphere is provisioning Oracle RAC nodes that take minutes rather than taking hours that traditionally used to take with running RAC on a physical architecture. So RAC on VMware vSphere, that's a perfect match. And the proof is in the pudding. The fact that we are able to run, or we ran numerous Oracle RAC on VMware sessions across these years. So the rule of thumb is to make this configuration work is that there must be 5 millisecond or less RTT, or round trip latency between the cluster nodes. Now, whether the Oracle RAC is deployed within the same data center or if it's across different data centers. So this is true for Oracle RAC and also for vSphere HA clusters. In fact, if you have the VMware vSphere Enterprise Plus licenses, that supports up to 10 millisecond. But when you're looking at Oracle RAC, the requirement from an Oracle RAC perspective is the round trip latency needs to be 5 millisecond or less. Another important thing to keep in mind, RAC needs shared disk. So just like in traditional vSphere, when you deploy Oracle RAC on vSphere, the shared devices requires what's called the multi-writer flag to enable the in-guest systems to leverage the cluster-aware file system that have distributed write or multi-writer capability, right? So the KB article 212.1181, that's for vSAN, right, running Oracle RAC on vSAN, and KB 1034.165 running Oracle RAC on VMFS file system that talks about the multi-writer support enabled for shared VMDKs when one wants to run Oracle RAC on a VMware vSphere platform. Another important point, starting vSAN 6.7p01, patch 01, Oracle RAC on vSAN does not require eager zero thick for the shared VMDK. So essentially, there is a lot of space savings for deploying Oracle RAC on vSAN storage.
So a proven feature of VMware Cloud AWS, there's actually a 15-year-old technology, is the ability to do site recovery using SRM. So be able to protect your VMs, and this could be any VM. It's not actually dependent on the actual infrastructure or the storage. As long as it's a VM and has a VMDK file, we can use vSphere replication to replicate that to VMware Cloud AWS. So in the event of a disaster, you can quickly go ahead and power on that VM and then recover it and continue operations as normal. So this is a feature that's an add-on to VMware Cloud AWS for customers that may or may not have a data center that's sitting there as a hot site or doesn't have enough capacity in that data center, or it's just cost prohibitive for you to outsource or buy that. You can spin up those hosts in Amazon very quickly, protect them with SRM, and then have that reliability of a very fast recovery time, even down to 5 minutes non-crash consistent or 15 minutes where it would be crash consistent. And then another option we have for customers who have workloads who have either a lot of data or data that changes very frequently. So you don't want to use something like SRM because it does require you to have the equivalent amount of hosts and storage available in the event of a failure so you can power on those VMs. So just like on-prem, you'd need to have a certain amount of servers and storage available to power those on. This is all backed by S3 in Amazon. So all of the replication occurs to that S3 bucket. And then in the event of a failure, we can do on-demand or pilot light mode where we have a minimum number of hosts and we remount those S3 buckets onto the ESX host and recover it. The pro side of this is it's for customers with a large amount of data. So if you have in the petabytes of data that you're protecting, the only disadvantage over SRM is the recovery time is not as quick. So recovery time is about 2 hours with this solution. If you need something that's very critical up in a matter of minutes, SRM would be the better option. But this is a much more price advantage because of the large amounts of storage are not being stored on the actual vSAN array that's in VMware Cloud AWS.
Okay. So essentially, VMware vSphere platform that provides many tools for customers to successfully ensure business continuity and disaster recovery for their business critical databases, right? So when talking about business continuity, there are basically 3 different levels, right, that can be provided. And even though 3 different levels are the same, when we want to provide disaster recovery for those workloads, essentially providing either BCDR at an application level or providing BCDR at VMware vSphere level, or providing BCDR at a storage level, right? So let's talk about business continuity first, right? Application-based business continuity, well, that can be provided using any of the Oracle-based tools. For example, using Oracle RMAN, using Oracle Data Pump, export, import, so on and so forth. When we start talking about the vSphere level business continuity, well, that can be provided using VMware technologies like Snapshot, VMware clones. So these are some of the tools that help achieve a point-in-time recovery, right? And when we start looking at snapshot-based business continuity, well, that could be provided using storage-based snapshots, storage-based clones, right? Now, on the flip side, when we start looking at disaster recovery, right? So for any application-based DR, that can be provided, Oracle in this case, that could be provided using Oracle-based tools. So for example, Oracle Data Guard, Oracle Active Data Guard, or that could be Oracle Golden Gate, or any third-party replication product, right? Now, when we start talking about VMware vSphere-based DR, VMware Site Recovery Manager, along with VMware vSphere replication, or even array-based replication, that help protects virtual machines, or even entire LUN or LUNs from partial or complete site failures by replicating the VMs or the entire LUN between the sites. So the VMware Site Recovery, VSR, that brings the VMware SDDC, disaster as a service, right, to VMware Cloud on AWS. And Ryan did mention about that as well. VCDR, which Ryan spoke about as well, that's an on-demand disaster recovery service, right? When we start talking about moving our or DRing our workloads to VMware Cloud on AWS, right? So the link at the bottom of the slide, that refers to the reference architecture that's in progress, that will, which basically dives deep into providing business continuity and disaster recovery, right? Keep one thing in mind, the choice of a business continuity or a choice of a disaster recovery solution adopted, that depends upon the application needs, that depends upon the SLAs, the RTO, the RPO, and so on and so forth. So the above business continuity and the disaster recovery methods that we spoke about, well, that can be summarized in the illustration in this slide here.
All right, so let's switch gears. We'll talk about hybrid cloud. So a few years ago, we introduced VMware Cloud AWS, and later since we have announced pretty much all the major hyperscalers with a VMware offering available from those particular vendors. So just listening to our customers' feedback, what customers really want is choice. They really liked what we did with VMware Cloud AWS, and if you were an existing AWS customer, that made a lot of sense. However, a lot of customers wanted some other options on which hyperscaler that particular VMware environment fell into. So we have partnered with Google Cloud, Microsoft Azure, as well as our smaller cloud program providers. And then also IBM Cloud has a managed VMware service as well. And then we recently announced late last year, Oracle Cloud now is able to run the full VMware stack, and you were able to migrate workloads to and from that environment as well. And then we've also got this ability using some of our HDX technology to be able to move between the different clouds. So you don't have to feel like you're locked in or stuck with one particular environment. You can easily move those workloads to or from each of those environments, depending on the feature sets that they offer. HDX may or may not be available in all of the hyperscalers, but it is definitely something that's on all of their roadmaps. So let's quickly go over the first cloud service that we created was VMware Cloud AWS. So this is a service that we built in conjunction with Amazon Web Services. It is sold and operated by VMware, so it's something that you would call VMware for support on for your procurement. It could still be transacted through AWS. So if you have a existing relationship and discounts with AWS, you could transact through them. But the point is, it's the same phone number you call for your on-prem. You would call the same support group for anything that's running in the VMware Cloud AWS. And it is running vSphere, vSAN, and NSX. It's vSphere 7, so same code that we ship on-prem. Just because we're running vSAN NSX to build this service does not necessarily mean you need those on-prem. So, you could have any type of storage if you wanted to do any type of vMotion or that site recovery manager or VCDR. It could be any storage and any hardware on-prem, but we run those components in the VMware Cloud AWS service. And then because we're in the Amazon data center, we have that close proximity to any of the Amazon services in a very fast connection. And as long as it's in the same availability zone, there's no egress fee between the two. There would be egress fee back on-prem, but it's at a negotiated rate through VMware at 5 cents a gig.
All right. So let's look at this reference architecture here. Essentially, what we can see is it's a 3-site lab setup, including the on-premises site A. That's on the left. You have site B on the right. And then on the top, you have the VMware Cloud on AWS. So essentially, the on-premises vSphere cluster on site A, that's running production workloads. Site B, that's running your dev, your test, and your DR workloads. Both site A and site B, they're in a hybrid link mode. Site A and site B vSphere clusters, they have access to their own dedicated storage. And site A is connected via layer 2 VPN to VMware Cloud on AWS. In this case, the VMware Cloud on AWS, that essentially is in a stretched mode. So it's a 6-node stretch cluster for VMware Cloud on AWS, and that is stretched across 2 AZs. So you essentially have 3 servers in AZ1, you have 3 servers in AZ2. Storage in VMware Cloud on AWS, that's provided by the HCI vSAN instance. So this current solution that designed and deployed 3 separate environments, right? So you had a production 2-node Oracle rack on site A, you had a DR 2-node Oracle rack on site B, and between these two, you have what's called the Oracle FarSync that sits on site A as well, right? So our use case is looking at migrating standalone Oracle workloads to VMware Cloud on AWS. So on a very high level, right, the Oracle workload migration from on-premises to VMware Cloud on AWS, that can be achieved in one of the 2 ways. The first way is using native VMware and Oracle methods. And the second way is using VMware Hybrid Cloud Extension, aka HDX. So in this section, we will use the native VMware and Oracle methods to migrate standalone Oracle workloads from on-premises to VMware Cloud on AWS. Right. So essentially, what we're trying to say here in this slide is, this is the use case about deploying these standalone workloads in VMware Cloud on AWS, and that's exactly the same as one would do as deploying the same workloads on premises. So as mentioned earlier, with VMware Cloud on AWS, ESXi hosts, they traditionally reside in an AWS AZ. They are protected by VMware vSphere HA. So this use case deployed an Oracle workload from a template. The operating system was OEL 7.4. It was an Oracle 12c, grid infrastructure, RDBMS binaries. We essentially use Oracle ASM filter driver. So all of the best practices for running Oracle workloads on VMware SDDC, that was followed in accordance with the best practices guide. Now, changing gears a bit, right? And with VMware Cloud on AWS, we've already mentioned that the ESXi hosts by default, they reside in a single availability zone protected by VMware vSphere HA. So there's a feature called stretch clusters for VMware Cloud on AWS, and that is designed to protect against an AWS AZ failure. So what can happen is applications can span multiple AZs within a VMware Cloud on AWS cluster, right? So the use case here is one can deploy Oracle workloads on stretch clusters for VMware Cloud on AWS, and in the event of any AZ failure, which is essentially rare, the workloads are brought up on another AZ without any breach of SLA, RP or RTO, and one can also load balance the workloads across multiple AZs. Right. So the second use case is essentially migrating single instance Oracle workloads from on-premises to VMware Cloud on AWS. Again, it's the same Oracle workload machine, 7.4 OEL, Oracle 12.2, grid infrastructure and RDBMS binaries. Oracle ASM was used to create those devices using Oracle filter, the ASM filter driver, ASMFD, and we use the multi-tenant option running pluggable database PDB1. Essentially using the same steps, right? Wherein we choose the migration method, we choose the resource pool, we choose the storage, we choose the destination network port group. One can seamlessly and transparently migrate these single instance workload from on-premises to VMware Cloud on AWS and back.
So on VMware Cloud and AWS, I mentioned we have HDX. So this is something that's included. It's actually some code we borrowed from our NSX technology to build out a suite of tools to be able to do what we refer to as long distance vMotion or migration to and from the cloud. So in previous version, we always had cold migration. You could just right click and move a VM. We had HDX vMotion that was live, but you had to right clicks, kind of sit there for a while it copied everything and then ensure that everything got copied over. We had bulk migration, but we now have these two new features that are much more geared towards business critical applications. One of which is bulk with OS assisted replication. So we actually have intelligence that we can see inside the OS, and we can quiesce the operating system before we actually do the migration to ensure that everything is calm. So we're not throwing a bunch of errors to the logs or locking files or anything like that. It is also a warm migration. So it's going to do a pre-copy, and then once everything is copied over, you'll see a powered off VM on the VMware Cloud AWS side. And then when we're ready to do the vMotion, we'll actually cut it over by powering that on and then copying the last written bits, the Delta files, as well as the memory over, just like a traditional vMotion. And then we also have replication assisted vMotion. So this will use vSphere replication on the back end. It'll only do a block level change copy of the VMDK file, so it's no interruption to the actual operating system. And this is a live migration. This can also be pre-staged. So you have two options to do it: just one quick move, or you can pre-copy and then schedule the move during a non-disruptive time, like a change window Thursday night at 9 p.m., for example.
So I don't know, Ryan, if we have time to go through the GCVE and the Azure VMware solution, so we can probably skip over that for sake of time.
Sure.
And the OCVS. So, but
just some other hyperscalers that we're running VMware on, but we announced those last year.
Absolutely. So as part of the wrap up, right? So essentially all collaterals for running Oracle workloads on VMware vSphere, the white papers, including Oracle on VMware hybrid multi-cloud, that could be found in the one-stop shop. The link at the bottom of the slide essentially will take you to the one-stop shop site. Please do attend the session. This is the session details for VMworld 2021. Bit about me. It's a bit about Ryan. But then thank you for listening to us, and thank you for attending our session.
Thanks, everybody.